Welcome to Business Leader Breakthroughs, where we help unlock the potential in you, your teams, and your business. I'm your host, Ryan Castle, along with Dr. Mike Ashby. We'll share insights, experiences, and stories on achieving breakthrough success in business and life. To learn more, click the link in the episode show notes or go to thebreakthrough.co. Now let the breakthroughs begin. Today's episode is a deep dive into AI. It's packed with valuable insights about artificial intelligence, how it really works, and what it means for business leaders like you. Full disclosure, this one is information dense, so buckle up because we cover everything from the basics of AI and machine learning to some of the cutting edge ways AI is already transforming industries like healthcare and astronaut selection. Our guest today is Bryan Russell, an AI expert with a PhD in the field, entrepreneur and advisor. Bryan takes us from his early days getting Hello World programs running on Python to using AI for selecting astronauts. He shares a wealth of knowledge and practical advice on how to harness AI in your business. If you want to find out how AI can surprise you, stick around. All right, let's get into it. Hey, Bryan, super excited to have you on the Business Leader Breakthroughs podcast today. Thanks so much for joining us.
It's a pleasure, man. Great to see you again.
Yeah. We should probably add the side note here that, Bryan, you are one of the advisors on our board and deeply valuing that, but, not to confuse anyone. So thanks for, we get the wonderful insight that you provide to us at a board level and just seem too good to keep all to ourselves. So great opportunity on the podcast to share it out to a wider audience. So thank you. Appreciate it.
Oh, that's lovely for you to say that. Thanks, Ryan.
Now, Bryan, normally when we do our podcast, I start off with some fast fact questions, ask our guests a couple of rapid fire questions so that the audience gets to know you. I thought I'd try something a little different today. Your area of expertise, or at least one of your areas of expertise, is deep understanding of AI. You've done a PhD in this area. You've done a lot of commercial enterprise around AI. It feels like you're evolving that knowledge every almost few minutes. I think it's changing that fast. So rather than ask you the questions, what I did is I went to ChatGPT, said, hey, I've got the wonderful Bryan Russell on my podcast today. How about I ask you the fast fact questions and see if you get them right? So let's have a little game here. I'm going to tell you what Chat said, and you can tell me whether it got it right for you or not. So first one is, do you prefer breakfast or dinner? Chat said breakfast.
No, I think I'd say breakfast. Yeah, okay, yep, I'd agree. Yep.
Okay, and Chat thought that because you're a high-performance operator and you'd want to optimize your mental and physical prowess early in the day, so getting some energy on board. So that was Chat's reasoning. Resonate, yeah. Maybe? Yeah.
Yeah, I haven't been watching some podcasts on intermittent fasting, but yep.
Second one, I said, would we likely, if Bryan was on holiday, find him hunting in the wild or relaxing on a pool lounger? And Chat said hunting.
Yep. Rather be dead than bored. So, got to be doing something active.
Yep. Some pretty good insights there. I asked what thought your preferred learning format would be: book, video, podcast, or article. Chat said, I'll let you ponder for a second.
Yep.
Chat said article or book. And the reasoning was, as a PhD and published researcher, he's probably wired for depth and citation-backed insight. Articles let him scan fast, books let him go deep.
Yeah, that's interesting. Yeah, I'd like the fifth one, actually, which is just chatting and conversation. So that would be my choice. If you had given me an unconstrained answer, it would have been interaction with people verbally. That was a good answer, yeah.
Preference of cats or dogs?
Oh, great one, actually. I love the company of dogs, but I really enjoy the individual personality and arrogance of cats. So I respect the cats, but I enjoy the dogs. Yeah.
So funny. Chad responded with something similar, saying, I think it'll probably be dogs, but let me grab the wording for the cat answer. Said, the independent strategist, observant, self-contained. You build tools that think just like cats.
That's interesting. Wow. Okay, let's really thought about that one. Yep.
Okay, early riser or night owl? Chat thought you'd be an early riser.
Yeah, definitely. Yep.
Yeah. And reasoning was around discipline as a through line of his career.
So I thought you'd be an early riser, so got that one. And then I said, what movie genre would you be watching if you're watching a movie? And chat thoughts, sci-fi or action thriller.
Hang on. Yep.
Awesome. Thanks for that. That was a bit of fun. And maybe after this podcast, I'll throw a few more questions into chat about Bryan Russell and see what I can find out. But that was great. Hey, Bryan, I wonder for our audience, could you just give us a bit of background on how you got involved in AI and what your kind of tenure has been and how you're at a highest level most often using AI right now?
Yeah, so I'm originally an electronic engineer from the late 80s, 90s. Spent about 10 or 15 years doing product design, and then I started my own company, and that was doing remote physiological monitoring of soldiers and professional athletes, and then patients in hospital and at home. And so through that 10-year period of running that company and then selling it to Medtronic, what I realized was as a technologist, we'd figured out that we could measure people, we could transmit it, and we could display it. But post selling the company and talking to my investors that were all happy that we'd sold for quite a nice profit, we came to the conclusion that we'd proved the technology could be implemented, but there was still this massive gap that experts, let's say a medic or a special forces sergeant, they weren't used to looking at all the engineering diagrams that we were presenting to them remotely. So AI back in the about 2010 to 2014, we didn't have large language models that back then, but AI did have the promise of actually doing the interpretation. And that looked like at that stage that we would not have to make our customers become geeks in the data we were presenting, but we could actually translate it and make it actionable in the way they were used to interpreting it. And so back then, probably a critical care doctor was about the only doctor that was looking at graphs and really understanding them. Everybody else was talking, reading notes, and using words. So post PhD, I did a really lovely stint for a few years at NASA doing clinical decision support, and that was specializing in assisting people making complex decisions. And then in 2023, as we all know now, GPT-3 and 3.5 came out, and it's been a roller coaster ride for the whole industry, learning how to get those tools into deployment, how to make them reliable as products versus experiments, and figuring out what they can and can't do, and how to wrap, code and other tools around the LLMs to make them useful. So we still use computer vision and other types of AI, but the LLMs have been the most transformative, or large language models have been the most transformative, because as humans, we read, talk, and write, and that's been the most easy way for us to implement. And from a business perspective, for the last few years, really from the NASA insight on, so we've done things like astronaut selection. So can somebody meet the standards to fly? And there's a lot of other different types of selection and standard comparison. It really is, how do we scale expert humans? So if we can implement something that's 95% as good as an experienced expert human, now we can have hundreds or thousands of them versus just that one. And so whenever there's a bottleneck of experts, when we can get close to that expert and scale it, often that is a brand new business opportunity that wasn't really available 5 years ago.
And the transformational impact for industry everywhere when you can achieve that is just phenomenal. And maybe we get a chance to dig into that a little today. Your understanding of AI is very broad, Bryan. We could probably make this podcast a 45-hour episode, given how much you know. What do you think would be really relevant, given our audience is often business leaders? They're thinking probably some of those questions around, what kind of is this AI? I kind of get Chat GPT, but what else is there? How should I be thinking about it in my organization, etc.? What kind of, at a highest level, what kind of guidance would you think is good for business leaders to be thinking about in this context?
I consider it like a stack of things on top of each other. So the US Marines has a cognitive model, which is how we make decisions, called the OODA loop, which is observe, orient, decide, and act. And I think in most business cases, what we're trying to do is actually enable or make decisions. So looking at a cognitive model that's taught to all the Marines and used in academia is probably a good way to frame how we think about these tools. So rather than starting with code and AI, what are we actually trying to achieve? And so I switched the orient to understand, because it's slightly easier for me to understand. So if we observe, understand, decide, and act, the observation may be sensors, it may be computer vision, it may also just be reading of existing text, right? And then we need to understand it. So that's the interpretation piece. And that may be an algorithm, just, A equals 2B. It may be machine learning, or it may be AI. But we're trying to get that context of what that raw sensor was. It may be counting photons, but now that's turned into a temperature. So say, we know how to use temperature. We don't know how to use 5 photons versus 6 photons, right? So once we've understood it, then we need to decide. So the LLMs can help us understand and give us explanation, but it can also help us decide. And there's an open, fun discussion on is AI creative? I would say yes, given the definition of, if you're talking to a human and they take 2 separate ideas and join them together for the first time to solve the problem in front of them, that's what we would consider quite creative. And every day, with the AI I use, even like ChatGPT, it's giving me new ideas that I haven't previously joined together. So I think that decisions and creativity is very useful. And then often in business, we were trying to make decisions on what to do. So our action, the last one in the acronym, often we want to know what are the choices, right? It can be very hard. That's why mentors and other advisors and colleagues are useful, because sometimes it's just we don't know what choices are available. And again, the AI can help us with choices. So if we have that OODA loop of orient, understand, decide, and act, and we figure out what tools we want to put beside that, such that as humans, now we are already doing our OODA loop on every business decision or understanding that we're doing, but we can now figure out how to put that together. So as a business leader, if you have this model of how is AI generally available to help humans, help our customers, help our internal people, then you can start looking for where's the opportunity. And so, just like in startup land, we look for a problem to solve. In business, we're always looking for the problem to solve, because that usually brings value. And with these types of tools, it's usually where we're constrained with expertise, or just a mountain of data. So I view the internet as 20 years of putting all human knowledge into a digital format. And Google search, we just get lost, right? Where do we go to find data? And so I view AI almost like a librarian for all human knowledge. So if we have these bottlenecks in our businesses, or even a single individual trying to solve a problem, how can we get AI to either deal with a volume of data and give us the 2 or 3 things that matter? Or how do we make these complex decisions, but because it's code, we can now parallelize that and make lots of complex decisions, and so free us from that bottleneck. So it's either volume or complexity, or sometimes there's a sweet spot where it's both. Medical diagnosis is probably the most common one. Legal work is a similar one that's been implemented fairly early. And interestingly, radiography, so looking at x-rays and so forth, is another example where you've needed expertise. You've got an undersupply of those expertise, say reading x-rays through all the hospitals. And so they've been very early adopters, because exactly that pattern has occurred. We need expertise at volume. AI was the most promising way to solve that problem.
In your understanding, how has that been utilized? The radiologist example, Bryan, is it now AI is being used to do first reviews of scans, and it's still being checked by a radiologist, but it's helping the radiologist be faster? Or is it a complete replacement of radiologists? Is it that good?
Yeah, that's a great question. I think the answer of that, just to step back a bit, is probably context based. And context, quite often, you're looking for a score. Do you have cancer? Don't you have cancer? But you're looking for the confidence the model has. So you got the score, the confidence, and the severity. So if I'm looking at, say, do you have melanoma, or do you have a headache? Where I'm going to use AI, and how much explainability and how much interaction with expert humans is going to depend on that. So with cancer, the computer vision, so if you look at that OODA stack, right? So it can computer vision can look at the X-ray, it can identify anomalies or classify what cells look cancerous and give them a score. It can give them a probability or confidence of that score. And then given the severity, then typically the human-based companies that are implementing it will make a decision as to whether that needs to have a human check it every time or whether it can be a screening tool and they'll check 1 in 100. So that really is context-based.
And when you refer to severity in that example, Bryan, what do you mean?
So the definition of risk in life is probability times severity. So if you have a 1% chance of having melanoma cancer, your risk of death is quite high. If you have a 99% chance of having a broken finger, the risk is quite low of death, right? It's not going to kill you. And that's a really nice way to view some of these, really we're building cognitive systems, right? Or decision-making systems. So is your business going to lose $1 million if this is wrong? Maybe we really want to check it out, right? If we're having to do 1 million decisions a day, and if any one of them we're going to lose 1 cent, we're probably happy to completely automate it and just statistically monitor it. So the risk to the business or the risk to a human changes their way. One of the really beautiful things that's happening with LLMs now is computer vision could highlight things, let's say in that X-ray, but the LLM, like the GPT models, can actually give us what's called explainability. And so we've been able to, so deep learning was quite a transformational change for us as engineers, let alone people using the products, because we had to black box it. If we had an algorithm like gravity, right? We know you're going to accelerate proportional to gravity and your mass. So that's an algorithm or algebra. So we could say if you are 1 kilogram and you're under 1 G, we know what's going to happen. Deep learning, it's a black box. We have inputs and we have outputs, but we don't really know what's happening inside. And that scared a lot of people, particularly in high risk situations where, well, hang on, I'd like to understand the why or the what if. And so LLMs actually have given us some way to get explainability. So if I'm doing a clinical decision support system, not only will I give, say, a score as to, can somebody fly to space or whatever, but we'll be giving them the explanation as to why that score was there, and maybe even the NASA standard as reference to that. So we've got references and we've got an explanation why that reference is applicable to this person with diabetes who's 65, is about to go to space, and the risk to a diabetic patient who's 65 is this. So the explainability allows us to somewhat understand what's happening inside the black box.
Super helpful. Bryan, I wonder if you can take us into maybe explanation around a couple of the terms that we hear a lot now. I'm not quite sure which order to do these in. Let me throw them at you. First one, can you give us a what's the difference between AI versus machine learning?
Yeah, that's a great one. At the top level, they're the same. So for most general conversations, they're the same. And I think AI is an easier acronym to say than ML or machine learning. So it's become thing. If you want to be strictly academic, AI is probably what we now call AGI, so closer to human type cognition. And so ML to a researcher in ML, they'll be quite strict on the definition of using ML. I have a hybrid in the middle because it helps me intuitively, train people and work with it on a daily basis. So I have a scale starting with algebra, right? Y equals 2x. ML, which is, I think I know the things that matter. And so if I measure these 3 things, I know I can group them and figure out, is it this or is it that? And so I'm still making some choices to prescribe what should be measured, how it should be calculated, but the ML is going to figure out how to group it, because that's going to change in deep learning, which is closer to AI, and what I would call AI, which is it's a black box. It's some neural network, and we don't know how the neural network specifically connected itself. And what we've done is we've trained it. We've given it lots of examples with lots of labels, like lots of cats and lots of dogs. And now when it looks at an image, it can tell us the probability that it's a cat or a dog, but we don't know specifically what it's measured in its millions of neurons. And so deep learning and AI, I think, is a nice way to view AI. ML is we're going to measure 5 things, but we're going to let the tool figure out how to group them. And then we've got algebra. We know how it works. We've got the maths for how it works. And we're just going to use that. And in general, if you can use algebra, you want to use algebra. Then go to ML. And then if you can't solve it, you want to go to AI. Because in business, we need to validate our products to prove they work. That proof or validation increases in time, complexity, and cost as you go from algebra to AI. So there's a very, very big operational cost as you go from one to the other. So I wouldn't advise jumping into AI or deep learning as a default. Typically, you want to start with the algebra. What we sometimes do is start with AI that teaches us what's possible, and sometimes we can step down to ML, or sometimes we can step all the way back to the algebra, and that's what ends up in the product and the business.
Very helpful. A couple of follow-up questions to that. The first one is, I think that helps me understand why we hear this term hallucination out of AI, and it's this, as you put it, the black box. There's millions of, did you call it neurons or neural pathways?
Originally, this modeling came out of people trying to make a computer version of a neuron, or the cell in our brain. And now a neural network is typically, when we put them all together, now it's called a neural network.
Okay. And that's why we sometimes get this hallucination element of AI, because we don't know what neuron network it is actually being down to return the answer to us. That's
actually an interesting one. And I view hallucination is related to another term called attention. And attention is a really nice model for us to know, both as leaders and is using AI. So attention, we have an intuitive feeling, right? If we talk to a 5-year-old kiddie and we want them to play in the sandbox, but not go and get muddy in the vegetable garden, we want their attention to be on the sandbox. One of the art of prompt engineering, or writing prompts, which is simply any query we give to ChatGPT, let alone in code, we'll give it to the AI model directly, that's actually directing the attention of the model. And so, if you take, say, a GPT model, which sits inside the website we call ChatGPT, when we ask it a question and it knows pretty much all human knowledge, that question is focusing its attention on the thing we're asking about. And that's actually the magic of prompting. And when we get good at prompting, one of the things we're considering is the attention we want the model to be focused on. And so hallucination can be related to that, because if our prompt is too general and it brings in something that we weren't actually asking about, that's one type of hallucination. The models have got better, but they can still suffer from making information up. And that's the more common version of hallucination. Sometimes we put examples in our prompting. So we'd say to ChatGPT, please solve this problem. And here's an example of the problem. A very common one, it can be quite difficult to solve, is if the next time it's asked to do something, it doesn't have enough data, or one of those inputs isn't available, it will go and take the example and merge it into the answer. And it's like, oh, hang on, that's from my example. That's not from the next case. And so that's a very common way to get hallucination. It's gone and gathered information because it's really wanting to give you an answer. And it's a probabilistic machine, right? So it's giving you the best answer it can. So if we're charitable towards the AI, hallucination really is, it's really trying to please us and give us the best answer. And if it has to join a few dots, it may do it. And that's where either the prompting from an attention perspective, or in the prompting, just tell it, please tell me if you don't know any of the things. Then it will be quite happy just to tell you that. So there's a way around hallucination, but it is definitely something related to attention and something that we should always be a little bit aware of. Just as if we're asking, an employee a question, they might make something up and it's just the same thing. They've just intuitively joined dots. And if we don't ask them the source of that information, arguably that's the same thing as hallucination.
I've got a really relevant example. We started the episode with a bit of fun using ChatGPT to try and estimate some answers around you. When I first did that prompt, I said, I'm having you as a guest on my podcast. His name is Bryan Russell, and here's his LinkedIn profile link. And the first response came back, and it was a different Bryan Russell. And I was like, no, that's not the right one. Please make sure you refer to the LinkedIn profile link that I gave you. And then it got it right. Exactly what you've described there is that example. And my sense is that predominantly sits with me because I didn't prompt it correctly to actually make sure I honed in on exactly the Bryan Russell I was trying to talk about.
The way you've framed that, you've understood there's a mistake, you've corrected via the prompting, but also you've taken responsible for the answer. In the media, quite often, the blame is put on the model. If I hit my finger with a hammer, it's not the hammer's fault. I would argue it's the same with AI. Understand how to use the AI, but take responsibility for how you use it and the response you get back. And that will help you self-improve and become better at it. And I think that's a really important lesson for any leader in business. At the very least, just as we all got very good at Google search, I think any leader that wants to be competitive within their job, let alone keeping their company competitive, they need to be playing with at least ChatGPT or one of the other free services to be getting the insight that you've just described.
Thank you. If there were a few key terms that every business leader should be across, probably top of my list, then I'll defer to your expertise here, Bryan, but prompt engineering, what is an LLM, and then what are agents? So those would be kind of my top three. So what else would you add to that list of you need to be across to at least be somewhat cognizant and be able to progress in the zone?
I think those are good ones. The other one I'd differentiate for people to understand is that there's a model, and then there's the product. And so, would you want me to go through them briefly?
Yes, please. That'd be awesome.
So I think we'll start with model. So the model is these neural networks, and they're layered. So there's some lovely YouTube videos on it. But if you imagine, a slice of bread, a loaf of bread pre-sliced. Each slice of bread is a layer of neural networks in 2 dimensions, all connected to each other, and then they get to talk to the next slice of bread, and on and on and on. Now, there's a few different flavors, so you might have sourdough, white bread, and brown bread, and the few different flavors in that loaf of bread. But what we do is we show the data in the first end of the loaf, and out the end of the loaf comes the answer. So that model starts really naive, just like a young baby. And by training it, some of those neural networks make stronger connections, and some of them actually say we don't need to be connected. And so it's trained. So if you take just a computer vision one, cat versus dog, we'll show it lots of cats and dogs. We'll tell it which one is cats and dogs. And those neural networks through the loaf have now got really, really good at saying cat versus dog. That's the model. And LLMs are just the same, except it's language. It's a large language model. So typically words, and now pictures as well. So we show it lots of words, and what OpenAI started to do, which now everybody does, it's expensive but amazing, is they showed lots of words to the LLM, and they asked it questions, and they got answers, and then they had thousands of humans simply saying yes or no, like swiping left or right. I prefer this answer over that answer. And they believed that was the magic, was not only did they get it really big around GPT-3, but the humans marking it actually somehow built in this human perception to the model. So, and it wasn't expected, it was discovered. LLMs were kind of discovered. So that model, let's say we have GPT-4o now, that's a model that sits within a website that we use as a tool or a product called ChatGPT. ChatGPT is a product. Underneath it is a model called, say, GPT-4o. Unfortunately, they've both got GPT in it, and so it's easy to, sort of like fuse them together in our brain. So understanding what is a model is important. The prompt is the text we give to the LLM model. So large language model, that loaf of bread, but it's now trained on language. Once they got really big into the billions of neurons, is the connections across each slice of bread, and then between the slices of bread, made just a massive amount of connections. And so you could ask about Napoleon and ask about Napoleon's mother and where Napoleon was born, and it would actually figure all that out because there were connections amongst each of those things. So it knows the definition of a mother, what is a mother, the history of Napoleon, because there's text about Napoleon, and in that text will be where he was born. And so while there may be no text that actually talked about all three, that neural network, because it knows the concept of those three, now makes those connections. And that's what's really powerful about the LLM. And so it's more than just language now. It actually understands meaning, concepts, and can join those concepts together. Now, if we talk about prompt, the prompt is the text we put into the LLM to drive its attention to get certain neurons to fire in that loaf of bread. So when it gives us the answer, it's actually made the connections relative to the thing we're about. So while we just ask each other questions and we start asking these GPT questions, if you start thinking a little bit more functionally about a prompt and the attention mechanism and what you want it to think about, that makes us quite a bit better at putting in the prompt that will give us the desired output. So an agent is a bit like your AI and ML question. The definition of agent is somewhat fluid depending on who you're asking. So the definition of an agent, regardless of whether it's a secret spy agent or software, is something acting with agency or independently. And so just as with LLMs, we can get it is somewhat acting independently anyway. But typically when we have a few different LLMs with different prompts, so we're asking it to act differently, when then they start talking to each other to solve a single problem, is typically when agents, the use of the word agents is used amongst LLMs. And so the typical one is to say, write a Twitter post or let's say a Reddit post. You might have 3 agents or probably 4 agents. You'd have a manager agent that says, I need to write a post. And to do that, I need to research a subject. I need to write it. And I need to probably edit it and check that it's actually on thing, just like 4 humans would do. And so what we can do is we can use the same model, but if we give what's called a system prompt or asking something to behave in a particular way, sitting on top of that model, that now will act differently than if the same model is given a different prompt. So if we have 4 agents to write the Reddit posting, they'll all use the same model, but separately, but with 4 different prompts telling them, I want you to be the manager, the researcher, the writer, or the editor. And then in software, we let them all talk to each other. If we say, please write a Reddit post about big pumpkins at Halloween time, they will automatically decide who should do the research, who should write it, and who should do the editing. And so we've now created 4 agents, but all we did was have 4 different prompts to the same flavor of model. And now we've got agentic behavior, and it's quite magical to watch. You'll actually see this, this conversation between them that no humans involved. All you see is the input and the output, and you can watch the conversation.
And what tool sets are being used to utilize agents?
That's an interesting one. If you were to watch YouTube, you'd see LangChain, Crew AI, AutoGen that are specifically set up to use agents. This field's changing fast, so anything we say today will be wrong tomorrow. But at the moment, agents are really good for, say, writing Twitter posts or Reddit posts for things like medical diagnosis that you need to prove validation. At the moment, I feel that agents are not ready for that because we can't validate them and we don't know what they're going to do next time in a controllable way under thousands of different situations.
Yes.
These agentic tools are really good at writing articles, but making serious decisions, whether it's life or death or, business decisions to do with money and customers. I personally don't use agents. I use a hybrid, which is called chain of thought. And so if I have a team of doctors that know how to do a diagnosis, I will implement software code that goes through that differential diagnosis process, just like they're trained at medical school. But for each of those stages, call them the links in the chain of thought, for each link, I will use an agentic approach. So that link has a particular job, ask the person about their family medical history, and then that agent now can do what's called dynamic questioning. So it's coming up with a question, asking the question, and then based on the answer, it may come up with another question until it's happy that it's got enough about your family history. And then that report of family history will go back into the chain of thought and move on to the next step in the chain. And that gives us a very deterministic or predictable type of questioning, because people are going to get confused if they get asked questions out of context. And also validate it. We can put in patient records. We can have those 5 doctors tell us what those answers should be throughout each of those processes. And then we can validate that each link in the chain is performing as it should and only asking about things that it should. So then we can go to production and release it into the marketplace with a measured accuracy and performance. Whereas just agents going together, imagine if you've been, you're going in about your diabetes and the system asks you about your broken toe that you broke on a skateboard at the age of 5. It's like, why is that relevant? That's a bit weird. We want to have production AI that is, we can prove is accurate and behaves in a very predictable way. And a agentic system at the moment, that's a little bit difficult to prove or to validate. We should note though that the field is moving incredibly quickly, and I feel that most of the models are extremely good now. Like everything's up, depending on how you measure it, they're all typically in the 80s and 90%. So where we're seeing improvement in production tools now is things around tools. So the LLMs originally couldn't access the internet, whereas now they can all do a Google search effectively. There's other applications like MCP, which is actually allowing the LLM to control your computer and move your mouse and your keyboard. Got to be very careful with that. But it's enabling some really interesting applications. So RAG, or retrieval of documents, that was one of the first tools that was added. So you've got the AI that was trained on, let's say, all human knowledge, but we want it to be specifically, back to attention, we want it to specifically understand something. So maybe we give it a medical textbook or a textbook about a particular industry that we want it to work on. And then they develop tools for it to go in and actually access that textbook on a case-by-case basis, figure out which chapter of the textbook and which page in that textbook was relevant to the specific query, and come back with a particular answer. What is the molecular weight of iron? I don't know. And let's say it didn't know it when it was trained. It could go into the chemistry textbook, pull out the molecular weight of iron, and give it back to me. So that specific domain knowledge is quite important. And from a business perspective, if you've got manuals, processes, and other documentation within your business that you believe is a differentiator and helps with your defensibility, those are the things that businesses are now encapsulating. And so if they're bringing AI as a product or to help their customers, it's usually that internal domain knowledge which can now be scaled. And what a magnificent opportunity for businesses to be able to take their domain knowledge, not give it away or publish it, but implement tools that allow them to scale with their specific knowledge in their industry.
Bryan, I'll share with the audience a really relevant model that we're using here. We've built a custom GPT, which has taken a lot of our leadership training knowledge around our active manager program, etc. We've built a virtual version of Dr. Mike, and we can now ask questions to that. So an example, we could say, hey, I've got a staff member that's continually turning up late to work. How should I address this situation? And with the AI contained and trained around our knowledge of how to do that, it's now going in, looking at all our content, going, okay, what you need to do is have a difficult conversation, courageous conversation in other people's terminology, but that kind of scenario. And then the AI will work you through our model of how we suggest a human approaches a difficult conversation, and it will walk you through that. And then you can prompt it with things like, how might the person that I have the difficult conversation respond? And it will then use the large language model underneath to go, well, they might be defensive. And if they're defensive, then this is how you can do it. They might blame someone else. And if they do, then this is how you can address that. So I think a super relevant example of exactly what you described, and then how we've implemented that to use the knowledge we have around how to lead people and put it into an AI format that's super accessible.
Yeah, and I think that makes the Breakthrough Company, state of the art in using its internal knowledge with AI like that. Not only has it taken, the Dr. Mike and all your guys' internal knowledge for that, I also know that you've done a lot of work on style and language and how to give results. So it's not just the answer is, it's how do you explain the answer as well. And that style of language is from a cognition and acceptability perspective is almost as important as the data that's given as well. And so I see the most successful teams implementing these tools just what you've done. You've taken AI expertise and you've taken a domain expertise and you've morphed them together. Just data scientists by themselves struggle to have effective products because they're missing domain knowledge and all the subtleties on delivering that, as well as the specific domain knowledge. So if they just ingest that domain knowledge automatically into their code, typically it's not a great product. And so at least two humans and an AI expertise and experimental, which you are, and the domain knowledge come together. That's what's making just absolutely marvelous products like what you just described.
So I guess that leads into really good guidance for organizations on where do they start. A couple of things we've observed and heard you talk about is at the very first level, if you're not yet, get in and start using some of these free tools like OpenAI, ChatGPT, and just experiment. So that would be one. Use resources like asking ChatGPT or whichever model you're using. If you don't understand something, it's really good at explaining it. And if you'd, as I sometimes do, can you explain this like I'm a 10-year-old? That's really helpful to get a layman's understanding of some of these things. You've mentioned some of the great resources on YouTube to more deeply understand some of these components if people want to do that. So there's sort of like the personal level of understanding. Applicability becomes personal productivity that people can use these kind of tools for. And then we can start working our way towards what is a business problem, or what is maybe more importantly, what is a problem that our client has that we might be able to solve, and how might we use some of these AI tools and components to solve that problem now. Iterations of that could be we're already solving it with human experts. How could we use AI tools to complement our human experts to make maybe some of the more rudimentary elements of their job more automated, so that we can remain the human element at the end? Would that be a reasonable approach to kind of getting started for some of these organizations?
Yeah, I think you've explained it really, really well. I think there's a few different ways to jump in. Clearly a ChatGPT or equivalent, Google and Anthropic and so forth are worth using. I personally would play with a few because they all are slightly different. And so you end up spotting patterns. I like Anthropic because it really specializes in giving you references. So it helps you. It's like a supercharged, Google search in a way. And once you've played with that, there's things called OpenAI assistants, so that you can actually drag in, confidentially some of your specific business knowledge or documents, and now you can get answers to that. That's generally quite disappointing, actually, because it's not guiding you through a process. It's just answering random questions. So quite a few people have done that, and I don't think there's been much success in that with people productizing just that. But it's a really good stepping stone to understand retrieval of knowledge. And then there's some choices on there, some graphical tools. So you can just join boxes together on the screen, no coding required. And then you can jump into coding. And Python seems to be, back in the 80s we'd use BASIC, and now everyone's using Python. And so starting gently with Python probably is a good way to go if you really want to start digging in deeply there. And Python has this concept of libraries, so it can do a hello world, but to do something specific, it really needs to load in up a few libraries. And there's some lovely tutorials on that. From a process perspective, I usually start with just to reiterate slightly differently the way you said it, I start with human processes. So what is the paper processes we're currently using? Where are the constraints in that, either complexity or volume of data, typically? And then choose a really, really simple, if it feels too simple, it's probably right, problem to solve. And then just experiment with implementing something, seeing how that works, and then iterating it. And within 2 or 3 prototype iterations of the product, I'd highly recommend people start thinking about how do they validate it. And so a systematic way would be, let's say there's a questionnaire. Let's say we're selecting a car to buy. And so if you came up with 10 ways to describe a car and choose 5 cars, So now you've got 5 cars, and you've got 10 categories against that car. And you choose, I don't know, a doctor, a soldier, and James Bond. And you'll make it artificial so it's very clear and obvious which of those people would choose which car based on what category. So now you've got what's called a gold standard answer for those inputs. So now when you train your AI up, you know the answer. And so now you can go, how accurate was it to choose those cars? And you need to change the prompts and the way you look at that to get the answer. What you've just done is prototyped a closed loop validation system. And once you've got your brain around a super simple validation system, like I've just described, then you can take that method that you've figured out and apply it to your business, which will be more complicated than what I've just described. And now you can actually present validation. So your internal colleagues are going to want to know, does it work? So they're going to want to know validation. Your customers are going to want to know, does it work? So they're going to want to see validation. And what I find quite magical, because validation sounds like watching paint dry, what it actually ends up doing, which makes it become exciting, it tells you where your design isn't working. And so it's, guess what? It's an attention mechanism. It's telling you where to pay attention or spend your effort to improve the product. And that's both efficient, but also quite marvelous, because imagine your customers are complaining and you've got this complex LLM, 10 links in the chain of thought. You just don't know where the problem is, but everyone's complaining. Imagine having a tool to tell you what's broken or where to fix it. And that's what validation does. So it helps you sell and make revenue. It helps you know where to work. So you don't have to spend 5 days on it. You can spend 1 day. But also things like hallucination and all these other downsides of AI, it's validation that helps you fix these problems. And so you become quite confident in releasing these products into the marketplace because you've done validation. If you haven't done validation, it's wishful thinking. And 9 times out of 10, your customers will do something you didn't expect, like any product, and things are going to break in unpredictable ways. And so the business is going to be quite rocky.
Yeah, it's great guidance, Bryan. Thanks for sharing that insight. Super helpful. I'd like to take us to the close of the podcast, and I'd like us to, I've got a couple of questions to follow up. But before we close out, is there anything further you'd like to make sure the audience is across?
One learning, and I think this is general across more than just AI as a market, there's people that are experimenting and executing AI that have opinions based on their experimental learnings, just like whether you're a painter, or anything. Then there's people that have strong opinions because they want to be involved, because there's a lot of hype at the moment. So anybody that's talking about ethics of AI, I kind of step back and ask, are they implementing, doing, or are they just talking? Because if they're just talking about the ethics of AI, it's maybe not that informed opinion. And so people that are writing or catastrophizing about AI may not be good advice. Because they're not actually executing. So it's not a knowledgeable opinion. They just want to be involved. So that would be one. The other one is, again, just like anything, small execution, no matter how naive or just playing with ChatGPT, will inform you as a leader and a manager when somebody with more domain knowledge, usually some young person that's implementing in the business, comes to you. So if the technology is used in your business, as a leader, you want some intuitive understanding of the risks, the rewards, and the things to manage both financially and from a project perspective, and also your spidey sense when someone tells you what they're going to do. And if it's possible, as a leader, you do want some type of spidey sense or intuition behind that. And I do think it's become pervasive enough that most people in leadership and management should be experimenting at some level, just as you wouldn't expect anybody these days to not know how to do a Google search. So pretty much everybody should be able to do some simple prompting and play with GPT to get a better answer than a Google search.
Love that. Good insights. Thanks, Bryan. To close this out, I wonder if we could each share a couple of AI tools or moments where we've been using something and just gone, wow, that is so cool. I love what that is doing. I knew this question is coming, so maybe if I go first, I'll just share a couple of examples. One I had today, I'm a member of the Entrepreneurs Organization. I have my forum group, and one of the members of my forum posted on our chat, hey, I've just asked ChatGPT what my life will look like in 10 years' time. So given what you know about me, what will my life look like in 10 years time? So we've all kind of done this, and I did mine, and I was like, wow, that is just like crazily on point. And yeah, no surprising. I've been a heavy ChatGPT user for a long time now. I've done a lot of queries around, personal life and fitness and health and business goals and all those kind of things. But what it summarized as essentially my desired outcome in 10 years was just like absolutely bang on. And then I said, oh, can you also create an image of what I'm going to look like? And didn't do quite so well in that because I had this beautiful full head of hair. So I didn't quite nail that bit, but the rest of it was pretty impressive. So that was just a fun one. And we are very heavy users of Fathom.video in our business for all our meeting recordings. Transformational, and there's rarely a day goes by that I don't look at the output that has created and just gone, wow, that is absolutely phenomenal. So there's a couple for me.
Yeah, my examples are going to be a little bit more geeky, I think.
I'm sure.
When I first started playing with a library called Crew AI, and that Crew AI is a crew of agents. And so the first time I remember when I was like 15 on an old Apple with a green screen, and I got Hello World to work, back in the 80s. To me, that was amazing. And that was a similar thing when I implemented 4 or 5 agents and then just stepped back and watched them have a conversation. To me, that was amazing, that they were actually talking to each other, not another human. At one of my companies, Ambient Cognition, we do medical diagnosis. And one of the big projects we've done in the last few years is astronaut selection. So if you're going to be a commercial astronaut, you may not be as healthy as one of the NASA astronauts. And so what are your conditions and how do we mitigate the risk of you going to space? And we started with 4 or 5 very experienced NASA doctors that were quite skeptical that AI could get anywhere close. And after 2 years of working with them, they went from skeptical to interested. They were always interested and involved, but very skeptical. Mm-hmm. And one of the latest demonstrations, they were actually giggling. They were so impressed. And they were asking the AI some really bizarre medical questions, which I'm not a doctor, I couldn't answer. And so to get these, basically grumpy old men to be